Hello everyone. In this session we are going to see how to draw zero sequence network for a three-phase transformer. So we know that in a three-phase transformer we have two windings. This is the primary winding and similarly this is the secondary winding. So this primary and secondary winding, it can be connected by using a star connection as well as with the delta connection. So there are various ways or the method of connections are there for the transformer. So let us see what all the methods of connections are there for the transformer. The first connection is the primary. So it is star connected and the secondary is also star connected. So this is the first connection. Similarly, so the primary is star connected. So here the neutral of the star system, it has been solidly grounded. So the secondary of the transformer is now delta connected here. Okay, this is one method of connection. Similarly, the third method of connection, so the primary is delta connected, the secondary is star connected, but the neutral is ungrounded. So this is the neutral, here the neutral is ungrounded. Similarly, consider one more method of connection. So here the primary of the transformer is star connected. So here the neutral is grounded through a reactor. So this is the reactor, the star is connected through a reactor here. And the secondary, so this is the secondary, it is delta connected. So likewise we can write many number of connections. Consider one more. So here the primary star connected, the neutral is grounded through a resistor, and the secondary is star connected, and here the neutral is grounded through a reactor. Similarly, the one more type, the primary and secondary both are delta connected here. So these are all some of the examples. So this is how the transformer, the primary and secondary can be connected. It may be connected in any of these form. So in your zero sequence network for a transformer, so we have one general configuration is there that can be used for any method of connection. So by using that, we can connect the transformer for a zero sequence for any type of connection it is. So now let us see, so what is the general configuration for drawing of the zero sequence network. So consider this is the general configuration for drawing of the zero sequence network. Okay. So this is how the general configuration looks for a zero sequence network for a three-phase transformer. So this is the zero sequence impedance, that is Z0, and this will be the reference bus. Okay. So totally in this general configuration there are four switches are there. So this switch we'll call it as S1 and S2. So these two are connected in series. So that we can call S1 and S2 as series switches. So S1 and S2 will be called as series switches. Similarly, there is a one more switch is there that is being connected in shunt. So that is K1 and K2. So here K1 and K2 are the shunt switches because they are connected in shunt or in parallel. Okay. So and this is the primary of the transformer and this is the secondary of the transformer. So remember here, so there are two switches are there connected in series S1 and S2, and two switches are there that are connected in parallel, that is K1 and K2. So now when to use this series switch and when to use this parallel switch. Suppose when the transformer is star connected, such a case we need to consider only the series switch. So remember S1 and S2 need to be considered only when the transformer is star connected. Similarly, so when the transformer is delta connected, such a case we need to prefer the shunt switches. So K1 and K2 should be used for delta connection. So very important here. Okay. So now as I told you, this is the primary side and this will be the secondary side of the transformer. So now primary side means which all the switch we need to consider. So observe here, so the switch S1 and K1. The switch S1 and K1 should be considered for primary side. Okay. Similarly, the switch S2 and K2 need to be considered for secondary side. Okay. So since we know that S1 and S2 these are series switches, and K1 and K2 these are shunt switches. So coming to the primary side means S1 and K1 switch need to be considered. So S1 is nothing but series switch. This is need to be considered only for the star connection. K1 is nothing but this is shunt switch. It is need to be considered only for the delta connection. Okay. And similarly, S2 is a series switch. It is need to be considered for star connection, and K2 is nothing but it is a shunt switch. It is need to be considered for delta connection. Okay. So very important, this general configuration. So the same switch configuration will be using for drawing of the zero sequence network for a transformer for any type of connection. So it may be the mentioned all the 6 type of connection. No, other than this also we will be preferring same general configuration. Okay. So before seeing one example, so now one more important thing you need to remember. So this is the star connection for a transformer. So here the star connection of the transformer, but the neutral is ungrounded. So in such a case, how we need to represent the system means it should need to be represented with the open circuit symbol. So open circuit symbol indicates that even though it is a star connected, but the neutral is ungrounded. Okay. Similarly, the second connection. So here this is a star connected system. So but the neutral is solidly grounded. Since we know that the zero sequence neutral, it can be in the form of 4 connection. Okay, this is the first connection, the neutral is ungrounded. So such a case we need to represent with the open circuit connection. Similarly, the second case is here the neutral is solidly grounded. So in such a case we need to represent with the straight line. So straight line indicates that it is star connected with the neutral is solidly grounded. So next, similarly, the one more connection, here the transformer or the system is star connected with the neutral, it has been grounded through a reactor. So now in such a case we need to represent the zero sequence as in this way. So this will be equal to 3Zn. Okay. Similarly, the last connection for the neutral, so this has been grounded through a resistor. So in such a case we need to represent this as 3 into Rn. So you know why it is 3 into Rn. You have seen it in the in the generator case. So the current flowing in the neutral will be 3 into Ia0. So that is why the impedance or the resistance will be 3 into Zn it is. So what are the things we need to remember? The general configuration. So S1 and S2 these are the series switches. K1 and K2 are the shunt switches. So series switches need to be considered for a star connection. K1 and K2 these are to be considered for the delta connection. So for the primary side means we need to consider S1 and K1. Suppose if the primary is only star connected means such a case we need to consider only the series switch S1 and K1 should be open. Suppose the secondary is a delta connected system means, so by that time we need to consider only K2, then S2 switch should be make it as open. So this is very important. Okay. So now based on this particular idea, now we'll see how to draw the zero sequence network for this type of connection for a transformer. Okay. So now let us see one example. So the first connection. So here the primary of the transformer, this is the primary side and this is the secondary side. So the primary is star connected and secondary is also it is star connected. Okay. So observe here. So this is our general configuration. So the same thing we are going to use it even for drawing our reactance diagram also. So I'll rewrite you once again for your understanding. So this is the switch configuration. Primary side, secondary side, S1, S2, K1, K2, and this is the zero sequence impedance Z0 and this will be the reference bus. So now by using the zero sequence or the general configuration, we need to draw the zero sequence for this particular connection, that is primary star connected, secondary is also star connected, but the neutral will be ungrounded. So what I told you, if the neutral is ungrounded means we need to show with the open circuit connection. Okay, so keeping that in mind, so now let us see for the primary side of the connection. So what I told you, so primary side means we need to consider the switch S1 and K1. So switch we need to consider for the primary as S1 and K1. So here, since it is a star connected, we need to consider only the series switch, that is S1. That means the K1, it is meant for delta. So since here there is no delta system is not there, so what we can do, we can make this K1 as open. So we'll consider only for the S1 switch. So how do we write the zero sequence network means? So by seeing this general configuration, so since the primary, the star system, it is ungrounded, so it is need to be represented with the open circuit connection. That means the switch S1 should be open. Okay, so we are making this connection open. Why? Because even though it is a star connected, but the neutral, it is not grounded, it is ungrounded system. So that is why we need to show it with the open circuit connection. So next we have one impedance is there. So write this impedance as Z0 as it is. So next we'll see for the secondary side. So observe here, even here the secondary is also star connected, but the neutral is ungrounded. Okay, so the secondary switches means S2 and K2. So these are the secondary switches. So as we know, S2 need to be considered for the star connection and K2 need to be considered for the delta connection. Since in the given circuit, so they are given only the star connection. Star connection means S2 should be considered. But this is an ungrounded system. So if it is an ungrounded system means we need to show it with the open circuit connection. And as it is, K1 and K2 both should be open. So this is the primary side and this is the secondary, and this will be the reference bus. So this is how you need to draw the zero sequence network for a transformer. Okay. So next, similarly, I'll take one more example. So consider here, this is the primary of the transformer and this is the secondary. So here the primary is solidly grounded and even the secondary is also, it is solidly grounded. So now for this type of connection, we'll draw the zero sequence network. So remember this general configuration. Okay. So by using this general configuration, we'll draw the zero sequence network for star connected and its neutral is solidly grounded. For this system we'll draw. Okay. So as I told you, the primary switches means S1 and K1. So these two are the primary switches. So observe here, since the primary, it is star connected, that means we need to consider the switch S1. So that indicates that K1 should be open. So as you know that, observe here, if it is a star connected and the neutral is solidly grounded means, so it should need to be represented with the straight line. Straight line means short circuit line also we can call. So now how we can write for the primary circuit as, so observe the S1 switch should be closed here. Okay. So here S1 should be closed because the primary is star connected and here the neutral is solidly grounded. So as the S1 is closed means we have an impedance Z0 is there. So we'll write that impedance Z0. So we completed with the primary side. So next similarly we'll see it for the secondary side. So even the secondary also we need to consider the two switches S2 and K2. So since it is a star connected, we need to consider the series switch, that is S2. So observe the method of connection for a star system. So here also it is the neutral will be solidly grounded. So what does it indicate? If it is solidly grounded means S2 also should be closed here. And what about K1 and K2? So there is no delta system is there. K1 and K2 should be open it is. Okay. So now we'll just draw one straight line that indicates that So it is both the system, primary and secondary, it is star connected and it is solidly grounded. So this is how to draw the zero sequence network for a primary and a secondary. Here the neutral is solidly grounded. So next take one more example. So in this example, so this is the primary side and this is the secondary side. So now the primary side, it has been grounded through a reactor. So this is being grounded through a reactor. Similarly the secondary, so this is ungrounded it is, or the neutral is not connected here. So now for this type of connection we will draw the zero sequence network. Okay, so again by using the same switch configuration, okay. So now primary side means we need to consider the switch S1 and K1. Since our given connection is a star connected, so we need to consider the switch S1. So S1 is for star connection, it is a series switch. So what about K1? So it will be open. So K1 will be open it is. So now, so this is a star connected, that means we need to consider the switch S1. Now look at the method of connection for a star system. So it is solidly grounded with the help of one reactor. So how do we need to represent if it is being solidly grounded through a reactor means? Observe here. So it should need to be represented with one reactance having the value as 3 into Zn. So same way we need to show here. So what does it indicate? S1 is closed with the help of a reactor, that is 3 into Zn. So like this way we need to represent our primary side. Okay. So now consider S1 will be closed. S1 will be closed with the help of one reactor, that is having the value as 3 into Zn. Okay. Same way we will represent here also. So S1 is closed, the switch S1 is closed through a reactor 3 into Zn. So this is for the primary side. So as the switch S1 is closed means, so to the next connected component is Z0. So write Z0 here. Okay. And here the open connection between the reference bus and the impedance, it indicates that K1 is not connected here. So the open connection between the reference bus, it indicates that K1 is not connected here. So now likewise see for the secondary side also. So this is the secondary, it is star connected and it is ungrounded. So now what does it indicate? Star connected, that means you need to see the secondary switch, that is S2. So since there is no delta connection is there for the secondary, K2 will be open here. So now K2 will be open, but the secondary, it is a star, even though it is a star system, but the neutral is ungrounded. So that means S2 is also will be open it is. So this is how we need to represent the secondary connection. Okay. So this is how to draw the zero sequence network for different methods of connection. So next similarly we'll see for a few more types of connections. So till now we have not seen for the delta system. So now let us see for the delta connection. So consider this is the primary side and this is the secondary. So now primary is a delta connected, secondary is also a delta connected system. So such a case, how do you draw the zero sequence network? So again I'll draw the switch configuration here for your understanding. So you always have a practice of writing the switch configuration. It will be easy for drawing the zero sequence. This is primary side, secondary side, S1, S2, series switch considered for the star connection. This is the impedance, zero sequence impedance, the shunt switch K1 and K2. So this to be considered for the delta connection, and this will be the reference bus. Okay. So now consider this. Remember this configuration. So now look at the method, the connection of the transformer. So here the primary is a delta connected. So primary side means we need to consider the switch S1 and K1. So now observe here, since it is a delta system, so delta primary is a delta, that means S1 should be open. Okay, as you know that the series switches, it should be considered only for a star connection, but since it is a delta system, so here S1 should be open. And what about K1? So K1 should be closed here. Okay, so likewise we'll show it for the primary side. So this switch will be open, S1 will be open, and K1 switch should be closed. So same way you have to represent. See, I am closing this particular switch K1, it should be connected to the reference bus, but S1 switch should be open here. So now draw the zero sequence impedance Z0. So this is for primary side. So next similarly look at for the secondary side also. So even the secondary is also it as delta connected system. Delta means, so we need to consider the secondary switches as S2 and K2. So here S2 is for series switch, that is for the star connected system. So that means S2 will be closed. So S2 will be closed. And what about K2? So K2 is considered for a delta system. Now here the star secondary system is delta only. So that is K2 will be, this should be open. This should be open and this one should be closed here. So here S2 should be open, K2 should be closed. So K2 is closed means here we need to close this switch. So this impedance should be connected to the reference bus and S2 should be open. So look at here, S1 is open, S2 is also open, only K1 and K2 switch that will be closed. So this is how to draw it for the delta connected system. This is when the primary and secondary both are delta connected here. So likewise see for the one more connection. So here the primary side, this is the primary and this is the secondary side. So here the primary side is star connected, so it has been grounded through a resistor, but the secondary side is delta connected. Okay, so now for this type of connection we'll see how to draw the zero sequence network. So now consider the same switch configuration. So primary switch means for primary side means we need to consider the switches S1 and K1. So these two for primary side. So now look at what type of, how it has been connected. So this is a star connected. So star connected means directly you can write K1 should be open, because star connection means we need to consider only the series switches, that is S1 on a primary side. So now look at the method of connection. Even though this is a star connected and it is a solidly grounded through a resistor, so that means it is clearly indicated that S1 is closed. S1 is closed with the help of one resistor which is having the value as 3 into Rn. So like this way you need to write. Okay, so since it is a star connected primary side, so K1 switch should be open, but S1 should be closed because it is a neutral is grounded with the help of one reactor. So it is closed with the help of one reactor. So same way we are going to show it for the zero sequence connection. So now what you have to do, so S1 should be closed here with the help of a reactor. So write one reactor, a resistor 3 into Rn. So after that there is one impedance is there, that is Z0. Okay, so this is the primary side. So here the open connection indicates that K1 is open. K1 is not connected to the reference bus. So next see it for the secondary side. So here observe the secondary is delta connected. So delta connected means it is clearly indicates that. So first we need to see the secondary switches S2 and K2. These two should be considered. So K2 is considered for the delta and S2 is considered for the star connection. But now look at the given connection. So it is given for a delta system. So delta system means S2 will be open here. S2 switch will be open and K2 will be closed here. So same way we will represent in our zero sequence network also. So this is after Z0 there is one switch is there K2. So this switch should be closed and S2 will be open here. Okay, so this is the secondary and this will be the reference bus. So like this way we need to represent for a system. Here the primary is star connected, the neutral is grounded through a resistor, and the secondary is delta connected. See, this is the general configuration for any type of connection. So the same configuration need to be remembered for writing the zero sequence for any type of connection. So lastly, we'll see one more connection, the sixth connection. Consider this is the primary side, this is the secondary. So here we'll see the primary is a delta connected and the secondary is star connected, but the neutral is ungrounded. Okay, neutral is ungrounded. So even for this also we'll consider the same switch configuration here what I have written. So now primary side means we need to consider the switch S1 and K1. So now look at the, so here S1 is for a star connection, K1 is for the delta connection. So now look at the given connection, it is a delta. So it clearly indicates that K1 should be closed, S1 should be open. Okay, so S1 should be open, K1 should be closed. So directly you can write, if it is a delta means it clearly indicates K1 switch should be closed, S1 switch should be open. Okay, so now look at this, S1 is open. So this indicates open connection for S1 and the K1 is closed here. So now this is being connected to the zero sequence impedance Z0. So this is the primary side. Okay. So now look at for the secondary. So secondary is star connected. So the switches to be considered for the secondary is S2 and K2. Since S2 is for series connection, K2 is for delta connection. So this is for star connection, this is for delta. So now look at what type of connection it is given. It is a star connection. So star system means K2 should be open. Okay, always the shunt switches should be considered only for the delta. If they given a star connection means directly you can write this should be open it is. Okay, so now S2, what about S2? So here even though it is a star system, but the neutral is ungrounded. If the neutral is ungrounded means it should need to be represented with the open circuit symbol. So that means here S2 is also will be open. Okay, so we need to represent like this way. So this open connection indicates that the secondary side is star connected and it is ungrounded. Okay, so this is how we need to draw the zero sequence network for a different type of connection. So likewise we can write many number of connections also, and for all the type of connections we can prefer the same switch configuration. So always remember S1 and K1. So these are the primary switches, primary side switches. S2 and K2, these are the secondary side switches. So series switches that is need to be considered for a star connection. K1 and K2, the shunt switches need to be considered for the delta connection. Okay, thank you.